Assalamualaikum warahmatullahi wabarakatuh. Selamat sejahtera. Okay, now we are continue our lecture with topic differentiation. Previously, we had discussed about the definition and the use of first principle. After that, we use the rule of differentiation. So today we will continue on implicit differentiation. Okay, so for implicit differentiation, this example we'll discuss together today. Okay, for the implicit differentiation. Okay, so this is the implicit differentiation. If you see here, implicit differentiation that cater for equation that involve more than one unknown, and we can see here we have x, then we have y also. Okay, for this, how can we find the derivative for this equation? Okay, this is what we call the implicit differentiation. Okay, so here, to do this, we use a procedure called implicit differentiation. This means that when we differentiate term involving x alone, we can differentiate it as usual. Like last week, we learned that all the equation had only one variable. But now, when we differentiate term involving y, we must apply the chain rule. Okay, what does it mean? Okay, so for example, 14, differentiate the following with respect to x. Okay, for this, previously we learned if we have 3x squared, we can answer it by to bring it to the front. Okay. It's hang. Okay. So previously we learned how to differentiate this kind of equation, which is if we have only one variable, which is x. So x here, we bring 2 to the front, then we get 3 times 2x power of 1, which is 2 minus 1 is 1. So it becomes 6x power of 1. Okay, then for number 2, okay, this is 6y square because of it involves only one variable. But for y, we have to put y prime. Okay. Compared to x, like previous we differentiate, we only put x, but here we have to put 6y square y prime. Bila masa kita differentiate y, kita kena letak y prime sebelah. Okay, so sekarang dekat sini contoh yang ketiga. Okay, kita ada 2 term dekat sini dan tambah. So then we have to differentiate y. Okay, so dia jadi apa tu? Differentiate x, it become 1 because of 1 power kuasa 1 letak kat depan. So atas ni 1 tolak 1 dia dapat kosong. Apa-apa yang kuasa kosong will get 1. Okay, so then this 3y, it become 3y prime. Boleh faham tak ni? Okay, 3y meaning that 3y power of 1. Okay, so sekarang dekat sini 3y 1 bring it to the front, so it get 3y power of 1 minus 1 will get 0. Then because of we differentiate y, we have to put y at the back, which is y prime. Okay, so this term will become 3 times 1 because of y power of 0 is 1, then y prime. So it becomes 3y prime like this. Okay, so here we have this is what we call product rule, because we have two things that times darab kan kat situ. Kalau product rule kita buat macam mana? Kita ambil X, which is X, bezakan Y kita dapat 2Y. Okey, bezakan Y kita dapat 2Y disebabkan kita bezakan Y, we have to put Y prime kat atas. Bezakan Y kena letak Y prime. Campur dengan, okey, this is 1. And okey, lepas tu kita ambil pula Y kuasa 2. Ambil je. This is product rule. X here, we differentiate it, we get 1. Okay. So, apa yang dia buat ialah, this is product rule. Ambil X, bezakan Y, we get 2Y. Dan belakang letak Y prime because of we differentiate Y. Then, plus Y square times 1. Okay. So, here, we can simplify it with 2xy, y prime plus y square. Okay, so sebelum kita nak pergi ke sini, okay, so kita pergi ke contoh 12 yang sebelum ni saya tak boleh nak buat sebab kita tak belajar implicit lagi. Okay, kita tengok contoh ni. Contoh ni dia nak cari pembezaan peringkat kedua untuk 2x kuasa 3 tolak 3y kuasa 2 sama juga dengan 7. Okay, nampak tak apa yang dia buat? Okay, yang ni ialah dia salin balik lah soalan yang atas ni. Okay, how can we differentiate this? We have to find dy over dx first, right? So, if we find this, we get 3 times 2 which is 6x square. Okay, so now we have to differentiate y. So differentiate y, we get 6y. So because of we differentiate y, we have to put y prime at the back. Okay, equal to 7 differentiate constant will get 0. Okay, for this, we rearrange this equation, then we put y prime at the as a kita letak y prime tu sebagai apa yang kita panggil ni, y sama juga. Okay, kita letak y prime dekat depan, jadi pembezaan pertama dia sama dengan negative 6x square divided by 6y. Negative 6y. Okay, so kat sini we simplify, we get this. Okay, but the question asks about this kuasa 2y which is second derivative. Second derivative, okay, yang ni kita tahu dia ada f, lepas tu kita ada bahagi dengan g. Okay, so kat sini kita kena buat quotient rule. So ambil g kita y ni, bezakan x dapat 2x. Okay, lepas tu kita ambil pula f. Kita ambil f kita x kuasa 2 kat sini, bezakan y. Y kita ni 1 ni, y. Y kuasa 1, bezakan y kuasa 1, we get 1 y, 1 tolak 1. Okay, disebabkan kita bezakan y, we have to put y prime dekat belakang. Okay, so kat sini ialah 1 kali y kuasa 0 y prime. So y kuasa 0 ialah 1. So yang tinggal ialah y prime saja. Okay, tahu ya kenapa dapat ni? Okay, so dibahagi dengan g kuasa 2, y kuasa 2. So sekarang dekat sini, okay, so this kind of equation kita ada y prime kat dalam tu. So because of we already know the value of y prime here, kita dah tahu dah value of y prime, kita dah ada kat sini. So kita boleh gantikan y prime kita ni ke dalam equation ni. Okay, so this is the substitution that we made. Okay, so here we times it with x square divided by y square, we get, okay, this is the second derivative. Okay, so this example involve implicit differentiation. Okay, so next is this is that we discussed just now. Okay, so how can we find dy over dx by given this? Okay, so here Nampak tak kat sini? It depends on you. If you want to put dy over dx or y prime belakang mana-mana pun boleh. Okay, so here bezakan 3y, we get 3y kuasa 2. So because of we differentiate y, so get belakang letak dy over dx. So differentiate y again, we get 2y dy over dx. Okay, then y again here, so 5 dy over dx, then this is the only x that we differentiate, so no need to put y prime at the back, which is only 2x. Then differentiate negative 4, we get 0. Okay, after that you have to factorize the dy over dx. So then the penyebut yang ada x tu kita letak sebelah kanan, and this equation we have to factorize out dy over dx, factor out dy over dx, then we get this equation, then dy over dx is equal to 2x divided by 3y square plus 2y minus 5. Okay, so we know that in implicit differentiation, dia punya bentuk ialah kita ada macam ni, ada y dengan x dalam satu sebutan, and finally we get dy over dx, dan yang lainnya semua pindahkan ke sebelah kanan. Okay, so this is the example of implicit differentiation. Okay, this is the formula for bulatan. Okay, one ni is our radius 1. Okay, so here this is not a function, but it will still be nice to be able to find the slope. Okay, kenapa dia bukan function? Sebab ingat lagi fungsi kalau kita lukis satu garis menegak dekat sini, kalau dia touch 2 times, dia bukan fungsi kan? Okay, tetapi it's okay. Here we want to differentiate it. Okay, differentiate this become, okay, differentiate x kuasa 2, differentiate y kuasa 2, dan differentiate 1. Okay, then we get x kuasa 2 dapat 2x. Then here it's involve y. So then when we differentiate y, we get 2y dy over dx and equal to 0. Okay. Okay. Okay, so sekarang dekat sini ingat balik tadi kita cari bila ada implicit, we have to differentiate x dengan y yang dalam equation, then our final answer will be in dy over dx is equal to what? So here we get, okay, yang 2x ni kita pindahkan ke kanan, then we get dy over dx is equal to negative 2x bahagi 2y. So sekarang we know this particular shape, the tangent for this particular shape is negative 2x bahagi 2y. Okay, so it is negative x over y. Okay, for this particular shape, this is what we call ellipse, and this is the equation of ellipse. Okay, determine the slope. Okay, remember, if we have this kind of question, they ask about slope, gradient, we have to solve it by using gradient first derivative. Okay, so here we do the implicit differentiation to get the first derivative. We get, okay, x square we get 2x, 4y square we get xy dy over dx is equal to 4. Then our final answer will be dy over dx is equal to, okay, simplify this, then we get negative x over 4y. Okay, here they ask you to find the slope at points square root 2 and y is negative 1 over square root 2. So here if we have this kind of slope dy over dx, then we simply substitute x and y value with square root 2 is our x and negative 1 divided over square root 2 is our y. Then we just substitute it into this dy over dx, then we get the slope for this particular point. Okey, so gantikanlah. So kita dapat slope dia ialah 1/2. Okey, this is the application of implicit differentiation in how to find a tangent in one shape. Okay, so application of differentiation, first is rectilinear motion or straight line motion, then increasing and decreasing function. After that is stationary point, and finally is second order derivative. Okay, rectilinear motion, what is mean? Okay, if we have displacement from the origin is a function, okay, x is equal to ft, then okay, this is what we find the halaju, which is velocity. Okay, velocity is first derivative of this equation. Okay, macam sebelum ni yang mula-mula lecture tu kita buat contoh halaju bas daripada Melaka ke Ipoh, tak silap saya. Okay, so sekarang remember back the velocity is application of first derivative. Okay, so then the second derivative is to find the acceleration, pecutan dia kan. Okay, so sekarang if we have this kind of question, satu body moving in a straight line, so that after t second its displacement x meter from a fixed point 0 is given by, okay, dia kata maksudnya satu pergerakan tu kita boleh wakili dengan this kind of formula. So then dia nak cari find the initial displacement, velocity and acceleration of the body. Okay. Okay, B, find the time at which the body is instantaneously arrest. Maksud kat mana dia rehat. Then if we want to answer first question, initial displacement tu, initial titik awal, maksudnya pada dia belum bergerak lagi, maksudnya pada T sama juga dengan kosong. T tu selalunya kita ialah second, ni kan dia beritahu dalam saat. Okay, so sekarang pada T kosong, initial displacement, okay, just masukkan T kosong ialah 0 meter, tiada pergerakan kan. Okay, so sekarang dekat sini velocity, if you want to find the velocity, we have to differentiate this into one first derivative, bezakan peringkat pertama, then we put lepas tu kalau initial, maksudnya velocity dia pada masa kosong ialah 9 meter per second. Okay, then dia punya acceleration ialah kita bezakan yang di x over dt ni, sekali lagi kita dapat 6 tolak 6t. Then if you want to find the acceleration at times t is equal to 0, then we get a is equal to 6 meter over per second. Maksudnya meter per saat kuasa 2. Okay, so here, okay, allow, continue. Okay, so here, increasing and decreasing function. Okay, this is the application of increasing and okay, yang ni dia buat, maksudnya kalau kita ada satu function, fungsi yang ni, yang hitam ni. Okay, so sekarang kalau kita nak cari gradient ni, ini ialah application lah ni, orang ni dia cari, okay, bila dia lalu dekat sini, okay, dia dapat titik ni ialah 0.24, okay, pada titik ni ialah 0.98, nampak tak kat situ? Okay, so kita boleh nampak bila dia increase, the gradient is positive, but here is decrease point. Dia menurunkan daripada titik ni ke sini, dia menurunkan, nampak tak? Value dia semua negatif yang ni bila dia menurun. Okay, maksudnya bila kita nak tengok dia menaik ke menurun, okay, this is the point where this function increase, dia meningkat. Okay, this is where the value is decrease, menurun, nampak dia negatif. And this is the point, okay, kosong ni ialah dia punya critical point. Titik, maksudnya kat kosong ni selalunya ialah titik maksimum atau minimum. Okay, kita pergi balik kat tadi. Okay, kosong kan tadi. Okay, then it start to increase again, then the value is positive, and here you nampak tak kat sini, value dia akan dapat kosong kembali. 4, 6. Sepatutnya dekat sini. Okey, kat sini ada satu titik. Sebab dekat sini is titik lengkuk balas tu. Okay, so sekarang it keep increasing. Okay, so here this is increasing and decreasing function. Okay, a function is said to be increased when the gradient is positive. Macam tadi tu lah, nampak tak bila titik tu increase, so the gradient is positive. Remember back in our tutorial how to find this gradient? Kalau gradient ni nak cari, maksudnya kita kena cari dua titik. Maksudnya cari satu titik yang dekat sini dan satu titik yang dekat sini. So cari M, which is M ialah Y2 tolak Y1 bahagi M2 tolak M1. Ni kita boleh assume apa-apa titik lah yang logik dekat sini. Ini kosong-kosong. Yang ini boleh ambil contohnya 3, 3. Macam tu, titik 3 dengan 3. Okay. So sekarang ni, this is how to find gradient. But we already know the gradient is the first derivative, right? So here, increasing, bila dia increase, bila derivative dia lebih besar daripada kosong, iaitu bila dia meningkat titik kecerunan dia tu ialah positif, lebih besar daripada kosong. Dan bila dia decrease, kecerunan dia lebih kecil daripada kosong, iaitu negatif. Kalau kecerunan negatif, kita tahu satu titik tu dia tengah menurun. Okay, then is the function increasing or decreasing at point x is equal to 3? Kalau soalan macam ni, maksudnya kita kena cari first derivative. Yang ni, x kuasa 3 tolak 6, x kuasa 2 tambah 2 ni, cari first derivative dia. First derivative dia ialah 3x kuasa 2 tolak 12x. So, soalan seterusnya, dia minta kita cari pada titik x sama juga dengan 3 ni, dia increase ke decrease. So, in order to know that this at this particular point, is it increase or decrease, we have to substitute x inside this and inside this. Okay, we get it is equal to -9. Then we can conclude that this is the point at point x is equal to 3. This function is decreasing, dia menurun. Okay, so untuk soal example berapa ni? Example 19. Suppose we want to know the range of value over which function is increasing or decreasing. Macam mana kita nak tahu the range dia decrease or increase? Okay. Here, find the range of value x for which the function fx is equal to x cubed minus 2x squared plus 2 is decreasing. Find the range. Maksudnya kita nak tahu dari titik apa ke titik apa yang dia decrease. Okay, so how can we find that? Okay, so sekarang tadi kita dah tahu bila kita nak tahu dia decrease, kita kena cari first derivative. So first you have to find the first derivative. Then fx is less than 0 bila masa dia lebih kecil daripada kosong. Iaitu first derivative dia negatif. Dekat mana? Okay, so sekarang kita kena cari nilai x dia di mana dia kosong dahulu. Maksudnya x is less than 0, maksudnya kurang daripada kosong. Okay, daripada ini equation yang kita dapat first derivative tu, kena carilah nilai x di mana dia less than 0 ialah pada, okay, this kind of solution will get you to 2 point of x, right? First is, okay, we can sketch the graph to find the range of inequality is true. So sekarang kat sini, okay, sekarang kat sini kita nampak tak kat sini? Kamu dapat x tolak 4. Okay, yang ni, macam mana kita nak dapat graf ni? X tolak 4. Okay, so cuba kamu, maksudnya x tu di antara kosong dengan 4. So dekat mana yang value dia negatif kan? Okay, so here from this kind of graph, kita ada kosong sampai 4. Okay, so sekarang dekat situ, nampak tak? Dia punya value yang dia negatif ialah yang dekat bawah. Yang merah tu. Iaitu the inequality x minus 4 less than 0 is true for the part of the curve that lies below the x-axis. So that we can conclude that our function decrease when x is between 0 and 4. Okay, this is the point where the interval where the function decrease. Okay. Okay. So sekarang kita nampaklah kat sini dia decrease pada 0 sehingga 4 punya interval. Okay, so here is the stationary point. Stationary point ni kita ada masa kita sebut dia sebagai critical point juga. Okay, so stationary point ni ialah di mana minimum point and maximum point tu diperolehi. Okay, so sekarang kat sini this is dy over dx is negative kat sini. Okay, dia turun, bila dia naik dia positif. Okay, nampak tak dekat sini? Minimum point ialah bila sebelah sini negatif, then have 1.0. Okay, this is what we call minimum point, which is from negative punya value, then 0, then we found positive. Okay, so daripada menurun, then satu titik minimum dia menaik semula. That is what we call a minimum point. Okay, so kat sini pula apa itu dengan maximum point? Maximum point ialah bila kita ada satu function, it keep increasing where dy over dx is positive, then we reach one point maximum where is dy over dx is equal to 0, then this will continue decrease where dy over dx is negative. Okay, so we know that maximum point mula-mula dia positive, then we reach the maximum point 0, then it become negative after that. Okay, so this is what we call stationary point, which is involve minimum and maximum point. Okay, next is okay. Ini just now. Okay, yang ni ialah critical point. Okay, stationary point also what we call is critical point here is point of inflection. Atau bahasa Melayunya kita sebut ialah titik lengkuk balas kat situ. Titik lengkuk balas ni ialah apa? Bila sebelah kiri ni dia positif. Okay, at one point it reach dy over dx tu mana tadi? Kat sini. Satu titik dekat sini dia dapat satu titik ni. Kosong. Nampak tak? Maksudnya dia positif, lepas tu ada satu titik yang dia the slope is kosong, then it continue positive. Okay, yang ni ialah titik lengkuk balas lah kita panggil point of inflection. Okay, and for the decreasing punya pattern, it keep decreasing dy dx negative, but at one point when the slope is 0, then it keep decrease, so we call it as point of inflection for decreasing punya function. Ini decreasing, dia menurun. Okay, just now maximum ialah satu value positif, lepas tu kosong negatif, right? And minimum ialah satu value dy dx negative, then we reach the minimum kosong, then we keep positive increase, right? So that's the pattern for the maximum minimum, and this is the pattern for point of inflection. Okay, after that is okay, next slide. Okay, so here example 20, we can find the coordinate of stationary point on, okay, by given solving dy over dx is equal to 0, then we get the stationary point. Okay, so if we have this question, okay, so now we want to find the stationary point. So this is the formula. Kita kena cari dy over dx, pembezaan pertama, then we equal it into 0. Kita samakan dengan kosong, then we find the value of x. So the x tu ialah where the stationary point exists. Okay, so x, okay, kat sini kan sama dengan kosong, so kita selesaikan untuk x ni, kita dapat x tolak 2, x tambah 2. So we have the 2 point of x here. Okay, Where is the 2 point of x is when x is equal to 2 and x is equal to negative 2. Ada dua titik kat situ. So, if we want negative 2, so we replace it into the original equation. So, here we get our y is equal to 23 by substitute negative 2 into original equation. Then the another coordinate for stationary point is negative 2, 23. Okay, this 2 coordinate point for stationary point. Okay, so we already determine our stationary point for this particular equation. Okay, then now we deciding the nature of stationary point. Okay, we can decide whether a stationary point is a maximum, minimum or point of inflection by working out whether the function is increasing or decreasing. Okay, maksudnya kita boleh tahu bahawa dekat mana minimum, dekat mana maximum bila kita tahu dia decrease ke increase. Macam tadi kan kalau kita keep decreasing, bila kita decrease menurun, lepas tu dekat satu point tu x sama juga dengan kosong, then we keep increase, then we know that this stationary point is minimum. Okay, so here this example we have to, we have shown that the point 2, negative 9 is a stationary point on the curve y is equal to x cubed minus 12x plus 7. Okay, let's see what happen when we have x is 1.9, 2 and 2.1. Okay, so sekarang kita ambil tiga titik ni. Macam mana kita ambil tiga titik ni? Maksudnya kita ambil satu titik yang sebelum 2, satu titik yang selepas 2. So kita nak tahu dekat titik 2 ni dia kosong kan. So kita nak tahu titik yang sebelum tu decrease ke atau increase, dan titik yang selepas tu increase ke atau decrease. So kita boleh tentukan untuk menentukan maximum or minimum point yang involved. Okay, so kita boleh letak macam ni. So 2 just now is our critical point, right? This 2, negative 9. So we have to put 1 point before and 1 point after 2. Okay, so here we replace 1.9 into first derivative, we get negative. Okay, we know here it decrease. And 2.1, we put it inside the dy over dx. So we found that this is positive. So it increase. So here the slope involved is decrease, negative. Then this is the 0, which is the flat horizontal line. Okay, after the horizontal line, we get the decrease value, which is positive value of dy over dx. So we can conclude at this point, it's involved minimum point. Okay, because of it decrease, then 1 point dia rata, then increase. Macam tu. Okay, this is the minimum turning point. Okay, then the second point, which is negative 2, 23. Okay, here we have to choose 1 point before and 1 point after negative 2. Okay, here this example, take negative 2.1, put it inside dy over dx, then we get 1.23. Then here is 0 because it is stationary point. Then negative 1.9, put it inside this equation, we get negative value. Okay, then here the slope for positive is increase, right? So we get increase. Then for 0 is a flat line, which is horizontal line. Then for the negative, it decrease. So we can conclude this stationary point is maximum value. Okay, which is maximum turning point. Okay, the main disadvantage of this method is that the behavior of more unusual function can change quite dramatically on either side of the turning point. Okay, it also time consuming and involves several calculations. Okay, this is another way how to determine whether the particular point is maximum or minimum by using second order derivative. Okay, how can we find the how can we determine the stationary point by using the second derivative? First, we have to find the first derivative. Okay, after we find the first derivative, we differentiate the function second time, then we can write it as d square y divided by dx square. Okay, the second derivative gives us the rate of change of the gradient of function. Then the second derivative can often be used to decide whether a stationary point is a maximum or minimum point. Okay, here by using second order derivative, if the second order derivative is less than 0 at stationary point, the point is maximum. Kalau inilah dia lebih kecil pada kosong, ini ialah titik maximum. And if the second order derivative is greater than 0, then we can conclude that a stationary point is the point where the graph is minimum. Okay, now if our second derivative is equal to 0 also at the stationary point, then the point could be a maximum or minimum or point of inflection. Okay, ini ada yang ni dia ada 3 bentuk. Sama ada dia lebih kecil pada kosong, maximum, lebih besar pada kosong, minimum, dan sama dengan kosong, whether it is maximum, minimum or inflection of point. Okay, in this case, we could have to use the method of looking the sign of derivative at either side of stationary point to decide its nature. Okay. For example, just now the equation like, okay, contohnya yang tadi tu yang last kali dia tak bagi contoh kan, but when we can use this particular contoh, which is, okay, contoh ni kan, kalau kita nak tentukan dia positif ke negatif ke, okay, cuba cari d kuasa 2x per dx kuasa 2 dia. Okay, yang ni ialah dy over dx. So kita cari dy d kuasa 2y per dx kuasa 2 dia sama juga dengan 6x. Okay, sekarang dekat sini 6x. Okay, 6x ni kita letak stationary point kita at point stationary tu. Sekarang kat sini kita dapat berapa? Negative 2. Okay. Kita stationary point kita ialah negative 2, right? So we put 6 kali negative 2. So dekat sini nilai dia ialah apa? Negative 12. So bila d kuasa 2y per dx kuasa 2 just now, dia lebih kecil daripada kosong. Maksudnya kan, ini ialah titik maksimum. Okay, by using the maklumat tadi. Okay, ni adalah titik maksimum. Kalau yang ni pula, yang first point tu, ni kan. Okay, kalau kita cari dia punya second derivative, which is d kuasa 2 x per dy kuasa 2 sama juga dengan 6x juga. Okay, kita masukkan 2 ke dalam ini, kita dapat positif, right? 12. Okay, when we have this is greater than 0, lebih besar daripada kosong. So we know this is the point minimum, right? Okay, so we no need to buat table ni. Kan kita boleh dapat daripada second derivative, kalau dia lebih besar daripada kosong, dia ialah minimum, dan bila dia lebih kecil daripada kosong, dia ialah maximum. Okay, apa yang saya nak cakap ni ialah by using second order just now to know the maximum and minimum point. Okay, so that's all for today, and please answer my forum to as an attendant for today lecture. Okay, Assalamualaikum dan selamat pagi.